Hello boys and girls. So as promised 2 days ago, today I will go through one of the white papers that came with the Libra release. That's one of the three white papers on Move. So the programming language for smart contract programming. And for starters, I guess I will read you the abstract, so in their words. This is the developers page with the documentation, and on one of the pages you get to the PDF. So there we go. It says, we present Move, a safe and flexible programming language for the Libra blockchain. Move is an executable bytecode language used to implement custom transactions and smart contracts. The key feature of Move is the ability to define custom resource types with semantics inspired by linear logic. A resource can never be copied or implicitly discarded, only moved between program storage locations. These safety guarantees are enforced statically by Move's type system. Despite these special protections, resources are ordinary program values. They can be stored in data structures, passed as arguments to procedures, and so on. First-class resources are a very general concept that programmers can use not only to implement safe digital assets, but also to write correct business logic for wrapping assets and enforcing access control policies. The safety and expressivity of Move have enabled us to implement significant part of the Libra protocol in Move, including Libra coin, transaction processing, and validator management. Okay, so far so good. So these, as I said in the video last 2 days ago, I get this with an interest with linear logic, and that's also highlighted here in the abstract. After reading a paper, what can also be mentioned is that what is also in the paper is by virtue of justifying the design of the language, they talk a little bit about the chain design as well, and in particular how the particular split that the language has compared to this other blockchain scripting languages in module and transactions, which are blocks in which procedures can run, and we will get to that in a bit. And also up front, one can say that this is an account-based design. So similar to how, let's say, token on the Ethereum blockchain are assigned to the address account, and so it's not UTXO, for example. So going back there, I've decided not to talk about type theory in this video at all, but just to mention it, what we are dealing here is a realization of this idea. I suppose it goes back to the 70s or 80s, of implementing type systems where you actually have to do operations exactly once, so you cannot do them more than once or less than once, and this is applied to the resource that is currencies in this case. And also, before we get into it, the project has this discourse page. There's not many, like this is just 4 days old, so there's not many posts in total, and the level is also quite different. But for me, it's noteworthy that the developers there appear to be talkative, and so it's nice. And also for discourse, it's nicely organized. I don't take that for granted. Okay. And also, I made videos, of course, that are relevant to this as well. So I talked before about smart contract programming, and I even have a talk on here. And most of the stuff I talked on the video YouTube channel before was smart contract programming on Neo, and I have some talks related to things we were going to see in the paper. Like I have a video on a debugger, and as well as the video that I did on elliptic curve cryptography. talks a little bit about how actually a transaction is assembled, and even how it is worked off by the blockchain nodes, like how the putting opcodes and operations on stack and so on and so forth. So if you have no idea about this, you will be able to understand this video, but nevertheless, let me do this advertisement, and of course subscribe to my channel, blah blah blah, and you might want to check out this video. I think here I have these videos where I talk about how a Bitcoin transaction looks, and how on Neo, in an old version of the debugger, you have the bytecode and how that functions. And also, the invention of different programming languages for different blockchains has a history. So we have a script that turns transactions you broadcast to the Bitcoin network to a sequence of bytes that then are executed in the network, and there's a certain logic to which transactions are validated and how the state of the Bitcoin blockchain is changed. And then there are blockchains like Ethereum, which runs Ethereum bytecode, which is a little bit more broad in what it lets you code, Turing complete blockchain language and so on and so forth. And then there are higher level languages like Solidity, of course, famously, but also Viper, which compile to the Ethereum bytecode, and also other languages like, I did some videos on the Neo blockchain, which do also coding in C#, which compiles to the bytecode that is saved and executed on a Neo blockchain. But also, for example, Cardano has this Haskell-like language to run on their settlement layer blockchain. And this, I point out this repository because not only are they actively working on it, but also if you look at the documentation, they actually have some discussion and notes of other protocols. I mean, it might not be all up to date and even 100% accurate. I remember pushing some corrections to this, but nevertheless, if you're interested in this, let me point this out to you here. And this is script, so this is from the Bitcoin wiki, and I've explained this in the elliptic curve video, but stuff like this, like different keywords for different operations running on a blockchain. We're also going to see this in this move paper. Finally, this script, and people have been, like, since this is already 10 years old now, almost, there are some interesting papers, and at one point I came across this one, Simplicity, which is a language for the Bitcoin blockchain, but actually has this like a fancy academic, anything even functional language description and so on. So also that might be interesting. It's something I picked up along the way at some point. Okay, so that out of the way, let me close this window. Excuse me. Okay. So, this is the Libra GitHub / Libra here. And so we're going to take a look at the GitHub first, okay? So get a feel for the language. Let's look at some examples of how it looks like, and then we're going step by step through what the white paper says. So here we have various things in this repository. We have the compiler, which of course compiles what you have to some bytecode executables, then the virtual machine in which it runs, then the bytecode verifier, which is described in some detail in the paper. So that's a tool for safety. And then already some standard library code in Move as well as Rust. The whole, like, this is, this is just the sub folder that concerns the language within the larger Libra repository. So there's a bunch of stuff, and we're just going to look at the language folder. I have to say though, this is released under, I think, Apache 2, so the kind of don't touch my code, don't use my code, and don't improve my code license. So purists in the crypto space might be upset about that. So be aware of that before you think about implementing it for your own stuff that you want to fork and so on and so forth. Okay, that said, let's look at this language/functional test subrepository. There's the test, and I take that because there are some examples so that we get a feel of how the language looks like. So we see here there's some modules declared, and then a script, and it accesses this public function that just returns this constant 42. So far so good. And here are more complicated examples. I'm not going to comment this. I have also, I have not run or compiled any of the code. I have just been going by the white paper and try to understand what I see on the GitHub. But it's just out 4 days, so I'm not very far with investigating it on a practical level. And I'm also not 100% sure to what extent features are already completed, and I suppose that more tests are to come. And at the end of the paper, they talk also about what they still have to do and how they want to spread the language that they develop here actually to implement other things within the language, maybe replace things that are currently in Rust, I don't know. Okay, but here we see this typical, let's say, blockchain lingua, right? So we have here a declaration of some variables, types, inbuilt types for unsigned integers. Okay, here some function that are not declared here. So this speaks about a context. We're going to talk about these modules and these kind of things. And also I want you to take note of this copy variable. So move is, as I explained in the previous video, tied to move semantics as they are in, you can find them in C++ and Rust. And I suppose because this is all about moving stuff around safely, that's where the name of the language from. And these functions, operations, move and copy, you will see them all throughout the code, and they are like a layer for protection. Basically, the whole thing is about writing simple programs as you find them on a blockchain, right? It's about changing the state of the global network. And this is just about separating components of the whole system in intelligible modules that make it harder for the programmer to cut themselves, right? That's what types are all about. If they don't explicitly help you with the interface that you're using, then definitely it's about let's say compile time errors, or in this case verification of typed bytecode and so on and so forth. Okay, then I've read this. I didn't quite get lecture from just looking at this. Since I have to do C++ at work, I don't know really Rust, and this sort of tests didn't disclose themselves to me at first hand, but we're going maybe if there's interest, and I'm going to look at this in another video and I find out what this is all about, then I'll definitely cover what is to be understood here. Also, especially in the last, let's say, 10 pages of this paper, which is 25 pages or so, there's a lot of structural explanation of layouts that will naturally be easier understood once you actually do your own Hello World programs and do actual coding. So the first 15 or so pages I will go to in more detail, because the other things are explanations of motivations and how the system looks like that. Once you actually program, you will better understand yourself, and doesn't have to be like taught in this way before I even actually use the language. Then we see here some primitives, actually a bunch, like different hashes and so on and so forth, and verification and signature tools. You also have these kind of abstracted calls in Neo and Ethereum and so on and so forth. It's also then explained in the paper where this resides, and some design decisions are elaborated on, and whether or not such primitives are implemented here or there, and so on and so forth. And here we see this in actual use in the code. Okay, some structs. Yeah, here's signature verification tests. Okay, am I over with the tests now? Okay, so I talked about this in the intro. So this is this account-based separation of the semantics of the language. Okay, and that's leaving these tests. Here we are in compiler territory. We have here a parser. If you like, I'm just pointing you to these kind of things if you're interested in checking out how this works. If you have a stronger background in Rust, then this will of course be easier to understand. But you see here a specification, and we will also see this in the paper then. And yeah, here you see some keywords that we'll also find later on. This is also, I think, just still the parser. This is exactly compiler. This is like this 1,300 lines file. There's really a lot of code already, I have to say, but also nicely documented. So I'm not too afraid of it. Okay, more compiler stuff. Signature implementation. This is the verifier. So these are tools then to verify if stuff is actually coded up correctly, and then it advertises then also in the white paper that before it actually can be ran on a chain, then it goes through this verification process. And it is explained, but I have not completely managed to make a mental picture of where things sit. So there's a language, and there's some intermediate language, and there's the bytecode, and you have these different aspects. And again, once you actually use the thing, then this will be clearer how this is set up. Okay, the virtual machine. Okay, so then that said, let's actually get into the paper. I've already written out the abstract to you, and I will just browse through this and go through my notes maybe. Here we have the introduction. They tell you what this is going to be about. And then they make this note for the audience. They say they speak on the one hand to the blockchain programmers, and then they warn, hey, at the end there's some language computer science design stuff, and on the other hand as well, like for you language people, we will also explain a little bit at the beginning what this blockchain stuff is all about. And then they have this, I mean, this is, as they also say, this is quite basic. If they say if you already know about blockchain, then you can quite easily skip this. They make this very general abstraction, but I think this is very nicely read. So very nicely like elaborated on, and you can make, like, even if you don't know blockchain, you can make yourself a picture of if you want to envision blockchain like that, and that's okay. Then there comes like 3 pages or so, which is really a little bit too basic to cover here, but they like systematically, step by step, explain what is actually the topic of investigation, what we want to do. They end up with explaining, obviously you have this, the state that is distributed over the network on different nodes, and then what we actually want in a language is a secure way, and all these buzzwords, flexible and whatnot, to do basically this. If there is a transaction coming in, then we verify that the person that wants to invoke a state transition on a blockchain is actually allowed, but actually has a fitting key and signs correctly. And then we have two addresses, like A to B, and we want to change an amount, like sending, right? And then if there's enough money and if the signature says, yeah, this is okay, then subtract from the address of the sender and add it to the address of the receiver. And what they talk about all the time is that this n, the amount, is handled just like a plain integer, and here is the focus on, like, this is naively speaking, not much is happening. It's all just wrappers and nice design, but this is all about like giving actually proper types to these resource objects and enabling a modular design of the contract. And then the separation of there you code up your modules, and there are transactions, and both are procedures, but they are like conceptually separated. And you have to read this probably yourself to coming from Solidity perspective, where probably most smart contract programmers are, to see which part is now actually in these modules, and where is the responsibly, on which side does the type system help me to not hurt myself, and so on and so forth. So this is what really this paper is all about. Okay, then they talk about the existing blockchain languages, and they talk about Script and Ethereum. And by Ethereum, most people will usually think of Solidity compiling to this bytecode. But also there's like Viper and whatnot, like different ways of writing contracts in a human readable way. And they emphasize, in fact, there is no type or value that represents Bitcoin Ether. And so here they will talk about this strawman coin in the previous section, which is like this simple example upon which they want to make the problem clear. So this is not a real coin. Okay, then language design, what do they want? This all makes sense, I suppose. Sorry. Yeah, and as I said before, the linear type thing is about moving resources around. I will make a video on where the motivation for this actually came from. But the emphasis is here that this is all hard coded already in the system. If you write stuff down, and since you already work with scarce research, since you declare the currency module that we'll be dealing with like that, then these are features where the compiler will actually complain if you do it wrong, unlike maybe some other scripting languages where you might accidentally duplicate resources and so on and so forth. Yeah, I found funny that they say Bitcoin script has a simple and elegant design. Well, from the semantics point, the execution is in a sense simple, but it's pretty like the language itself. If you look at the code, it's pretty bulky, I would say. But okay, they just want to be nice, right? Yeah, and they emphasize always the bytecode. I'm not even sure if they mention Solidity here with Ethereum. Okay, but that's just something I noted. Okay, then at this point, I think I talked about it now. They talk about resources, and this becomes the first class object, as they say. Okay, And yeah, here this is also important. Then here comes in this talk about the separations. Again, if you're interested in that, I will not like make this video too long, but they jump around on this point a lot in the paper. They speak about how now where is it? A module declares resource types, and we will also see this in some example. Here some of the features. I just highlight them, okay, so that you see some things I found notable. You don't have to go through all this, or you know already the highlights. Here's the emphasis on how this might like differ from like an object-oriented approach. These modules that they speak about. Yeah, so here is how they categorize the type of executable we're dealing with. The bytecode verifier comes into the picture. Later they will have a separate section on that. Here's it, the verifiability. Yeah, and this is all very boxed, which in a nice way, and then there's also like different access to the global state inside the language. And here, for example, there's often like there's talk of borrowing from global, and this is a lot about how in which ways different accesses can be granted, and what you have to set, and it's oriented in the Rust language, where you give only this reference to objects and only once at a time. So there's aspects where the safety comes in. So then we come to move itself. After this motivation, we have some example code. So this is one code where which implements this, taking money from one address and giving it to the other. This is called, like the script is invoked by the transaction sender, and the payee is who receives. And so the coin, according to the amount, is declared here. This is the module. This is this type of this coin, and then this module is accessed. And these are all things that are deployed, as this is my understanding anyway, on the chain or whatever, like DAG data structure they have. This is I have not read in detail the other two papers. The one is about the blockchain data structure, and the other one is about the protocol. But understanding the semantics will be necessary to fully understand, of course, the language, the target that targets the chain. And then, okay, this is basically the miners. Withdraw from sender, and this has implementation. Some of those are shown in the next page. And there are these wrappers, right? This amount copy and move, and these guarantee that you actually move the coins and that you don't move them twice and whatnot, right? I'm not going to explain in full detail the semantics behind it, because I also don't really understand it yet perfectly. But there you go. So you can see, I highlighted this. There's a lot of about wrapping code that you would also understand from Solidity, but here it's just like a type system pinned down to what is essential. And so I'm not 100% sure about the strength of the language as such, and because I've only seen simple calculation examples and moving around coins, and it might be that the whole setup is also just for this type of application, they will emphasize in a picture that you can create modules under different addresses and so on and so forth on the chain. But I don't know to what extent, like if you speak of decentralized applications, that will be possibly how far it will break out of that. But I think there's not a point to criticize in either way. If it's meant to be restricted, then this is a good thing to do. I'm not a Turing completeness fetishist. I think this is like a little bit over the top, because Turing completeness in the end is just having while loops, roughly. Okay, they mentioned the move semantics, and then they explain in detail what is possible and what is not possible, and why that ought to work. Yeah. Okay, and then here it's all about the module system, right? And again, I have to see this in in practice, but they speak about having two kinds of programs, or like boxes for procedures, let's say, and there are transactions, and then there are the modules. And so this 0x 0, 1, and 2, these are like three accounts basically, and then they exemplify how these different accounts can have these modules deployed. For example, this guy has my module 2, 3, and so on and so forth, and how different resources are coded up and deployed on this. And here they explain then how a transaction script is a single use piece of code. So I'm not sure from the operational flow if this is more than just sending a transaction that invokes something on the chain, or if this is also uploading code and having it verified. And so how this operates, I don't know yet exactly, but they really emphasize this module deployment difference. So compared to Ethereum, maybe the module is like the smart contract, but then they have a more refined, I suppose, context set up. Because then in the end bytecode is also typed, they say. I'm not sure how this looks on the Ethereum blockchain in comparison. So this is just my thoughts going through this. Here's an causary example of setting up a module with a coin. Or how it is set up already for the main currency, that is Libra, and they say that this is from the implementation status also just like another currency basically, that this has not a special position over other currencies. So if we then go to this example, this is the deposit. I think this is like, sorry for scrolling so fast here. Here we have the deposit method in the currency module, and of course I use the word method and so on. I don't know what the perfect nomenclature according to them is already done, but here's this implementation, and this is a little bit more intricate, but because here we also have this built-in call. So this is depositing, and like it will end up with the to deposit amount being added. So being deposited. And this is the plus in the end. And before it gets there, there's this intricate chain of passing allowances and so on and so forth, and references. So we have these references, and all the immutable access to the data structures are these references, And then we have access to global aspects on the chain, so beyond the box, I suppose, on chain. And for this we have to understand the semantics of the ledger better. But here they explain to you then how this amount is unpacked and destroyed, but the value is captured here, and then the coin type, I guess, is captured with these references and from the other module in the global state, and then from the existing, from this reference, then the value is obtained, and the reference to this value, and then eventually the deposit value that was accessed here can be added and then written back. So this is my understanding anyway, and this is explained in detail what happens here. Yeah, this is best understood probably writing the code. Similar here. This is even a longer chain. So we have here the withdraw operation. I think we also saw it before. Here's an assert. And here is a method. I think this is that reads from the transaction that is currently being sent or used to invoke the state transitions of the chains. So again, if this is part of module code, then there's this interaction with the transaction that is incoming, and this explains the example, and that's it for this. Okay, and after that they explain the language abstractly. So we have these elements of the global state that are these partial functions. There's always this interplay with IDs and addresses and then some structures, and they explain then how this breaks down. Basically, this is like a graph of the data structures, and they go on and explain this. So we're not going to like jump through this in full detail, but so from my notes, they talk about what they have for structures, and then emphasize their design, which I suppose is like what I like is they sometimes explain pros and cons and why they choose different things, and this is all helps to build a practical compiler around it so that you can pass it out correctly, I suppose. I have highlighted that. So here's again this transaction aspect. Okay, so this transaction versus module thing, and there are no function pointers or virtual calls, so more details about their outlook on things. And this is also to simplify the interaction of contracts. Then next they have the section on the bytecode interpreter. They talk about their decisions with respect to stack versus register, and here motivations for gas costs. And then the rest of the paper is pretty much more elaboration on the structure, but again, I would say let's skip this until we have actually ran some code. A short chapter on the virtual machine that puts all together. And let's maybe highlight this here. Yeah, this is of course the outside. So this is a very computer science perspective on things, I guess. And finally, point out that they aim at eventual parallelization of the and claim that they have set it up in a way that this will be possible in the future. And finally, talk about things they have to implement, and especially they emphasize how they want to make things simpler for the developers, and then have a note on third-party move modules and so on and so forth. So most of the crypto projects are MIT licensed, and I'm not sure about the implications of the broad band of implications for Apache code. I guess it will make it harder to experiment, clone and set up systems and have people participate. But I'm not certain about these issues. So this is just in case you find this is very nice, but want to set up your own system. Be aware of the license issues. Okay. Finally, the rest is then a more formal, let's say, specification. There are different ways of formulating languages, but they are more or less succinct. You have all the keywords that we already saw in the GitHub before, and a bunch of references. And I guess that sums up pretty much the paper. Write me if this is interesting. Of course, I sorry for making possible mistakes, since I have not used it and it's only like 4 days old. If you want me also to cover the other 2 white papers, technical white papers anyway, then let me know, and have a good Saturday.